Good afternoon, and welcome to the Revolutionizing Healthcare, Enhancing Resiliency, Reducing Operational Expenses, and Addressing Labor Shortages with Train on behalf of ASHI today. I first want to say a huge thank you to all of you that are in attendance as we celebrate Facilities and Engineering Week. Thank you for all that you do behind the scenes that may seem like it goes unnoticed for what you and your team do, but you really are truly creating um, exceptional patient care. You are creating resilient facilities and leading teams of technical and skilled labor that we so desperately need. So I just want to extend a huge thank you, and we will get started. So just a little bit of train of who we are. So have great brand recognition for being foundational chiller company. We have a wonderful brand recognition in many of your facilities, hopefully around the country and around the world. But really, Train goes beyond, and we actually are a leading building technology company and an energy services company that can provide energy services agreements and projects to drive energy savings while upgrading aging infrastructure. So we want to be part of your mission in helping provide that exceptional patient care and meeting your compliance needs and hopefully helping when there are labor shortages and being a supplement to your team. So today we hope to take you through a little bit of where technology has been, where it is now and where it's going. So I'm Christy Fetch. I am the healthcare vertical market strategy leader for North America for Train Commercial. Today I have with me Dave Hostetler, who is our digital controls leader. He will be our subject matter expert on all things autonomous control and AI. So I'd actually like to start with a poll. When you hear the term AI, what comes to mind? Is it A, someone like Rosie from the Jetsons, where she's a friendly robot looking to make our daily lives easier? B, just funny, comical relief, right? AI generated videos and antics that can promote creativity. Or C, an unstoppable cyborg symbolizing fears and ethical concerns for what's to come from these robots. So we'll give you a few seconds if you would, please respond, and then we'll check in with results here momentarily. Okay, let's check in with the final results. So we're seeing across the board, we've got A and B are tied at 42%, and then we've got 15% coming in at B. So I was a big fan of the raccoons bouncing on the trampolines. I think I was duped there for a little bit, thinking it was real, and I do think that that's something that will be a challenge with AI and going forward of what's real and what's been created or AI generated. But so ultimately, we're seeing the positives. There's split that we can see the positives in the daily life and how it can help us, but there's concerns of the ethical and what will that look like in the future. So how did we get here? I think that this was something interesting to go through to show where did we start with technology and how are we all the way at a point where we're doing machine learning and we're doing where everything is very cloud based or at the palm of your hand. And so if we look back to when computers, first started coming around in the early 1950s, then we jump into email and the World Wide Web. We get into the wireless internet, but I think the largest change is around 1991, 92, when handheld devices really started to take flight. Something that I want to bring to everyone's attention on this webinar is if you have staff that are born in 1990 or later, they know nothing else but having life with technology at their fingertips. And so it is a native piece of their life. Whereas for folks, like me and my team, we are born prior to 1990. And so it's something that we have had to adapt to and continue to learn. But I think it's important as you're managing your teams to understand that if they are from younger generations, this is not foreign to them, and that they are going to expect this to be part of their career, no matter what field they're going into. In addition, now we are going in, we've got the everything went to cloud-based, right? You probably have a lot of data. They're talking about virtual servers. And now we're going even deeper into artificial intelligence. With that, we need to allow our minds to be open to how do we allow this to help us with our future tasks. Today, in the clinical space, we are already seeing artificial intelligence being used for um, paying for reimbursements, looking at clinical diagnosis and images. And so it will be coming to the building side. So looking at it from a building automation, we've started, I'm sure in many of your facilities, you have a combination of building automation, maybe pneumatics or just manual control, all the way up through, you've got great, great enterprise-wide building management and everything in between. So today, you may have remote access through an iPad or through a remote server, remote desktop that you can get to. But think about, what do we do with autonomous control? How do we move from individual equipment control all the way up to looking at it as an environment and as a portfolio as a whole, and how we can allow technology to do our jobs more efficiently, to supplement our staff, and to reduce steps, honestly. And how do we take thousands of points of data when we started in history with 0 points of data, and now one piece of equipment can drive thousands of data points a day or a minute or an hour, depending on what you've selected. And what do you do with that data is what's really impactful. So I'm going to turn it over. Oops, let's see. Real quick. So mindset shift, right? We've got these challenges in the healthcare environments, and we want to take a step back and look at each of these challenges. How can we use technology and data to really drive these as opportunities? So now I will be turning it over to Dave.
Thanks, Christy. So on that previous slide, we had a lot of challenges or opportunities depending on our frame of mind, right? In terms of the things that we have to worry about in our facilities every day. And a couple of those that we can put into a couple of those really big buckets are, buildings are our largest asset class in the world, right? In terms of energy usage and just square footage and those things. So the largest asset class, and it's largely operating, even with the advances that Christy talked about, largely operating the same way it has for years. So when we talk about those challenges, we can, from a building automation perspective, we can think of sort of two big buckets. Buildings waste a lot of the energy that they consume, and there's not enough skilled labor to address that waste and to fix the deferred maintenance challenges. So two big buckets of challenges, right, around wasting energy and labor shortages sort of across the spectrum, whether that's skilled technician labor, whether that's property managers, whether that's energy engineers, the whole sort of gamut of those skilled labor gaps. But when we look at the buildings of today, even the most take a new facility that's just commissioned, has a brand new building automation system in it, is still in that first category there of purely reactive and rules based. Most of our building automation systems are programmed in a way that if something happens, do this. If something else happens, do that. It's all very rules based in terms of, and it's reactionary to the world around it. And in many cases, it's blind to the external factors. So in the case of most building automation systems, their only connection, other than remote access, their only real connection or to the outside world is a temperature and humidity sensor on the roof that may or may not be accurate, right? Like that's the only way that it knows sort of what the environment is. And we don't often do a lot with the data that these systems collect. So they have the power to collect a lot of data, but we don't often do a lot with that. So as we talk through a couple of use cases for AI and in terms of addressing these challenges today, one of the things that I want to start with is this idea of getting the building connected and being able to normalize data. So you notice here on the screen here, I'm on the second building here, getting connectivity and data and normalizing that data. I don't want to sort of rush over the fact that this is a non-trivial step, right? Like the idea of, and especially when we're looking at large complex buildings like hospitals and portfolios of complex buildings, the data that comes in from those buildings is from the disparate building automation systems that you likely have comes in differently. Like we might name a point one thing in one building, it might be named something else in another building, it might be named two different things within the same building on two different pieces of equipment. So in order to be able to use AI and drive decisions at scale, we have to normalize that data. And so we have to use some kind of schema. We use Haystack in terms of being able to normalize that data, knowing that what is that point, that's turning on the fan and off the fan and driving the speed, and coming up with a normalized data set. So once you have that data that's connected, you're normalized it, we know what all the points are, we can look at that across the portfolio. This is where deep learning really allows us to create predictive capability. So now we can transition from a mode where we're purely reactive and rules based to something where we're looking forward into what the building is going to do. And there's been any number of solutions in the market over the last few years that are marketed as something along the lines of, they give recommendations, or they fault detection that provides recommendations, but it still requires a human in the loop to actually go do something, to go change a set point, to address something. Where we're at now with technology is the ability for AI to see an opportunity to change a set point or operate more efficiently, and to be able to take that action reliably and drive those savings without a human having to take an additional action. And we can optimize to multiple objectives. So energy efficiency, comfort, decarbonization, equipment health. So because we have this forward-looking capability, it's not just about energy savings. It truly is about making the equipment perform better and ensuring that occupants are comfortable. And as we talk about, beyond just optimizing, schedules and set points, we get into leveraging that data to actually enable the folks that operate that building every day to do more with the time that they do have, to shorten their time to get information, to troubleshoot, and to go through that. So we're going to talk more in depth about all of this, but really the idea here is this progression of, there's going to be additional opportunities once you have that data connected, once it's normalized, once you start to deploy some of these technologies, adding the new things that come out, whether it's, next week, next month, and the pace of innovation in this space is really, really fast. And so the idea of getting your building connected, getting the data normalized, and starting down this path by leveraging the things that are sort of available today is a great place to start. And we can go to the next slide. And so, when we talk about, I'm not going to go in depth with this, but, the idea that we have a wide variety of, controls and platforms that are out there, and the ability to pull all of these things into one cohesive data layer that allows you to access it and make decisions and drive outcomes is really important, especially as you have large portfolios that have multiple vendors in them. The ability to pull them together in a way that makes sense and pull that into a single system and make decisions is really important. Go one more. And so when we talk about, sort of what is AI for HVAC, and I'm talking through this through the lens of the product that we call Train Autonomous Control. Um, um, we we talk about, this connection to this data. We connect that, and we collect the data, every 5 minutes, all day, every day. We combine that with weather and occupancy, and we are able to basically create a thermodynamic model of that building using deep learning. And so this is, being able to model a building is not unique, but the ability to do this under multiple conditions and redo this model every 5 minutes and make predictions around what the building is going to do and be able to adjust set points in real time and adjust sequences in real time. That's really the power of what, the AI and the compute can do these days. And that's really so these are things that, energy engineers have done for years and coming up with, but we've done it with spreadsheets, we've done it with fault detection, we've done it with human intervention, and now we can take advantage of AI being able to do it in real time. I see a question over there in the chat that I'll answer live here about, are we able to add water treatment data as well? Generally, yes. You can pull, if the system is able to talk, if we're able to bring that data um, in terms of, what it is that we're trying to do. The question I would have is, what decisions are we trying to drive in terms of utilizing that data? If we're just bringing it in for visualization, yeah, absolutely. If we're trying to drive when do we need to do maintenance, um, yeah, there's definitely a use case there that we would have the ability to add water treatment data. So when we think about um, optimizing buildings or refining energy and operations, um, we tend to think of this in what I'll say a three-legged stool here. And so when we talk about an optimized building portfolio, starting over there on the left-hand side, starting with efficient equipment. As Christy mentioned in the top, this is sort of this is in Train's DNA. This is what we've done for over 100 years, is build efficient equipment. However, even if you have the most efficient equipment in the world, you have the chiller with the lowest kW per ton, or the most efficient rooftop. If we run it at inappropriate times, if we ask it to do inappropriate things, you're not going to come up with an optimized outcome, right? So that's where we talk about control sequences and autonomous AI or autonomous control. The ensuring that we're using that efficient equipment in the most efficient way possible all the time. And then finally, physical maintenance. Even if I start with efficient equipment, I run it at the optimal times, at the optimal set points, eventually someone has to go service that piece of equipment. And so, how do we leverage AI and data in terms of empowering the folks that actually have to go do that work to be the most efficient time spent on site as possible? So the idea around making sure that, that technician that we're paying a pretty penny for, that we're maximizing the amount of time that they're spending physically in front of a machine fixing it, as opposed to looking up data in an IOM, as opposed to searching for parts availability, searching for through the IOM for a parts number, that kind of thing. So the ability to generate and get information to those folks that are actually doing the work. You can go on to the next slide. And so the last one, um, in terms of, what is the AI optimization doing? And this is always, one of those interesting um, sort of conversations around, is it operating the system differently? And fundamentally, the laws of physics are still the laws of physics, um, in terms of what are the levers that we're going to pull to optimize energy consumption and improve occupant comfort. And it's the same three levers that we pull through, traditional programming or some of those things. And the first one is schedules. making sure that equipment runs when it should run, right? Like that we know what the building schedule is, and so and whether if that's 24/7, okay. If that's an outpatient clinic that should run, kind of office hours Monday through Friday, well, let's make sure that the equipment runs when it's supposed to run. And only then set points, making sure that we have appropriate set points in terms of what is the goal of the equipment running. So are we maintaining reasonable space temperature set points and those kinds of things? And finally, sequences. How do those systems operate together to achieve a goal? Right? So when you think about even a simple variable air system in terms of a rooftop that has a fan, you've got compressors that are cooling the air, and then you've got VAVs with reheat in them, balancing all of those things and coming up with the most efficient way becomes very complex very quickly in terms of doing that calculation or that programming. And this is something where machine learning and AI is really good at being able to see what are all the possible outcomes in terms of um, the different ways we could run that system. So I see another question over here in the chat that I'm going to go ahead and answer them. So how does AI integrate when the system needs to be run manually? Can this potentially cause a safety concern? And so um, I would say in terms of what we're talking about here, we're talking about allowing AI to actually make decisions, and so we're not in a mode where we're allowing the system to run manually. However, this is one of those important points that the way that we do this at Train, we do this in a way that doesn't remove control from the operator. That the overrides that we do are visible and can be overridden at a higher priority, and we always ensure that there is basically a lockout button so that you can go to the building automation system, hit a button, and disengage the AI from doing optimization, and that can be used for maintenance for some of those things. So um, at the end of the day, the operator is still in control of their building. So we try to minimize that those safety concerns. And also, we have if the building is not behaving as we would expect, or there are constraints that are being um, not being met, the AI will actually disengage and return to local control. So we do have things in place for that. Now, that being said, understanding that there are portions of healthcare facilities that maybe we just don't want to deploy this kind of technology. Maybe the operating room's not the place we start. However, maybe the less immediately critical spaces, typical patient rooms, administrative areas, those other things, maybe we do there. So we do have that ability to um, sort of pick and choose. It's not an all or nothing. We can say we want to optimize the 80% of the facility where it makes sense and leave the other 20% operating in its local control. So hopefully I answered that question there. And so another way of just sort of talking through what it is exactly that we're talking about in terms of this autonomous control. So we connect, we're pulling all of that data that we talked about from the HVAC system, BAS data, historical trends, and then we're connecting um, to other data sources. So we connect to a weather station that's very close to each site. And that's not just for temperature and humidity. We're also looking at things like uh, angle of the sun, um, cloud cover, all of these different things that are going to change the way that building behaves to come up with our model of how that those spaces within that building are going to behave. And we use that to forecast conditions with a high accuracy. So the ability to decide, what that building is going to do, what the load is going to be in the future. And based on those outputs, we can simultaneously model all of the different ways that we could run that building and optimize for energy, um, occupant comfort, and equipment wear. So we actually have some data that shows a significantly reduced equipment cycling. So things like if we have a rooftop compressor, we can model how many fewer times we cycle that compressor during the day. So it's not just about energy savings, it really is about driving optimal performance across all of these areas. So got another question over here that I'm going to go ahead and answer live. So in terms of retrofitting to an existing facility, can you extract or utilize existing data and trending to feed into your autonomous program to aid the deep learning curve? So this is something that we're working on today. We don't use existing data, but what we have done is our learning curve is pretty short in terms of how long we need to watch the building in terms of that learning cycle. It's measured in weeks, not even months, that we need to observe a building before we're confident enough to begin making decisions. So we're always looking at ways to speed that up and using existing data and if we have that stored is one of the things that we're looking at. So I'm not sure I understand that next question, but maybe Ron, it says, isn't this already being done through CPLs? Maybe we can expand on that question a little bit. Custom
Yeah.
programming.
So what I'm
Yeah,
thinking of,
so
like the custom programming, it came up, I noticed that the question came in when we were talking about like the cloud coverage and the weather. So I would personally say yes, today we are using some weather data, but it's really just analog inputs of temperatures, humidities, and not taking into dynamic conditions. Would that be accurate, Dave?
yeah, sort of along those lines. And really this is the sort of the crux, right, of the ability to model all of the different ways that you could optimize that building. And it's something that's just a limitation of what controls can do and how complex the programming becomes to go through what that modeling looks like. And so if you have a really if we go back to the timeline that Christy had at the beginning of manual control to building automation system to all those things, if you have a really really highly optimized building and you've invested in doing the very best um, you know, optimization programming that's possible in controls. Is AI going to save you a ton on top of that? Maybe, maybe not. Is it probably going to outperform even the best programming? Yes, it will. But at that edge, candidly, there is, a is the juice worth the squeeze at that very edge. But we can talk about some of the other things that we can use for the data in term when I talk about the second product I'm going to talk about today. But so yes, a lot of the approach is the same. The difference is in that predictive capability and the ability to model, many different potential optimization profiles all at once. So this is just an example of one of the sets of results that we have, and this is one of the ways that we do measurement verification is to model the same building over the same period of time, um, or two different periods of time with the same outdoor weather conditions. And so you can see this is combined RTU and reheat KW, so the total KW of a variable air system. And you can see what it did without AI for HVAC control and what it did with. And so you can see the ability to hold, the reheat and make sure that we have, appropriate set points coming out of the rooftop. And this was a building that did have, some optimization programming in it, but the AI was able to perform better over the same conditions. And so what can we do and what can we expect in terms of actual results? And so if we focus on that box over there in the right, we can talk about a reduction of HVAC energy costs, typical 10% to 25%. And I want to be really clear here, I'm talking about HVAC energy costs, not total meter, right? And so if we think about, in typical buildings, HVAC can be somewhere between, call it 40 and 60% of total energy, perhaps a little less in a facility like a hospital, but somewhere in that ballpark, so that, translates to somewhere in the neighborhood of 5 to 10% total meter, somewhere in that ballpark. But then have corresponding reductions in carbon emissions, equipment service life, up to 50%. So again, we've had some really compelling data around reduced compressor cycling. And again, utilizing this predictive capability, being able to improve occupant comfort. So basically reducing thermal excursion. So spending more time much closer to set point. So those are the typical outcomes we have in terms of deploying autonomous control. So pretty compelling all on their own.
And before we move on from this, I think that it's important to look at this from a healthcare lens, what to expect. So, the EPA says that for every $1 saved in energy cost or energy spend, that's equivalent to $20 based on a 5% operating margin. That's equivalent to $20 in revenue for a nonprofit. And that's real money that you don't send to the utility company, you can keep in-house and serve your patients and add to your mission. I also think of the extended equipment life as actually a plank in resiliency, right? It's one of the steps in building resiliency of your infrastructure. And we're looking to say, we we have a question about, can we repeat the statement on the EPA? And I'm happy I can make sure that you get the link to the EPA stat. But essentially, it is for every $1 in energy spend reduction, it is equivalent to $20 in operational revenue if you have an operating margin of 5%. So as your operating margin, if it goes down, that equivalent revenue is actually going to go up. It's going to be higher than $20. And so looking to keep the money inside your organization to support your missions. So then we go to extending equipment life and equating that to resiliency. And then lastly, improving occupational comfort. There are studies that say that that can increase productivity, that can increase retention of labor in non-HVAC fields. So I think it's just really important that when we're looking at this, not only from an HVAC lens, but from an overall clinical lens.
All
Go
right,
ahead.
so we talked about, sort of the first use case for AI and utilizing the data that comes out of your building, and that's really around driving those outcomes. That second leg of the stool from the beginning when we talked about optimization. So ensuring that the equipment is running at the right time, that it's running to the right set point, and it's doing so in the most efficient sequence possible. The second sort of use case for AI and the ability to use the data coming out of your facility, you're going to hear me talk about a product called Aria. And so what this is an AI agent that actually allows you to talk to your building. And so if you think about that third leg that we had up there around physical maintenance and enabling the people that actually use their building, that are responsible for maintaining the building, whether that's technicians, whether that's property managers, whether that's operations managers, we can think about all those different personas. But how do they get information, and how do we shorten that time to allow them to get information from their building? And so we can talk through sort of, some of the things that an agent like this or agentic AI allows you to do. So in terms of doing reporting and data visualization, um, empowering faster decisions because it can deliver real-time recommendations, doing fault resolution, helping you identify root causes, um, allowing you to actually take control and fine tune schedules and set points, and maintenance optimization. So we'll talk about some of the things that where um, there are opportunities that this technology is going to grow over time and sort of gain in both capability and speed, but really helping you drive some optimization in your maintenance program. And so when we talk about, ARIA as a virtual building agent, we can think about the things, in terms of foundational capabilities, and we can think about the things that it's going to do in the future. But really, this is where we start talking about, and it comes back to that one of the questions we had earlier around, um, where is the data coming from, and what are all the sources of data that we have access to be able to drive some of um, these outcomes. And so, there today, right now, the product that we have in the market, um, we can ask Aria questions like, I'm getting a comfort complaint at a specific building or one of the buildings in my portfolio. What are some issues I can address while I'm at a medical office? Um, what are some things that, or please plot the compressor cycling patterns for the last week. And these are all things, and there's probably some folks in the back of their mind saying, "Oh yeah, building automation systems can do that," and they absolutely can. And full disclosure, I come from a controls background and have spent a long time in Train's controls business, and yeah, we can do all of those things. But it takes somebody that has been trained, to understand how to use that building automation system, that knows where the menu, that has the right access, that can go click on the right things and go through the reports and find the data, right? Where something like Aria, and I'm sure those of you out there have used something like ChatGPT or one of these other agentic AI or generative AI programs, where you just have to ask it a question. You talk to it in your own words, and it responds to you. And so when we think about sort of, the ability to talk to or combining the power of a large language model with the telemetry data that comes out of a building automation system, you can see how we can start to answer some of these questions. When we look into the future, and when I say the future, this is in the very short term, things that make this, even more powerful. So if we can also integrate to something like your work order management system, if we can feed the AI, the manuals for the equipment that you have in your building. Um, if you stock your own replacement parts, or you have a partner that stocks parts, what is the part number, where is it in stock? So can we connect to these other systems? Can we give the AI additional information, and can we allow those that need this information to go to one system instead of going to a building automation system, seeing what the problem is, going to another, either flipping open a hard copy of an IOM or looking up the IOM online and flipping through it? Is there a way that we can shorten that time? And so this is really the power of something like a product like Aria, is combining all of these systems into one, allowing you to talk to it in your own voice in multiple languages even, and allowing it to provide you the information that you need to make decisions. And so we talk about, some of the different skills that Aria has, and we can talk about some of the different um, sort of use cases. And I talked about, and I think the one that most people, sort of gravitate towards or um, think of immediately is enabling a technician, right? So somebody that needs to troubleshoot a piece of equipment, somebody that needs to perform maintenance, and that certainly is a strong use case. But other use cases around, um, people that operate buildings and maybe are not as technical, maybe don't have the background, and they know they're hot in a space and they need to know, should I call a technician? Who do I call? What do I do? And maybe some of our clinical buildings or outbuildings, we don't have a full-time, building engineer there, and there's somebody that, works the front desk that has an additional duty of being sort of the building operations person. How do we allow them to get information? How do we allow them to, utilize the system in a way that makes sense? And again, this ability to talk to it in your own voice, to do things like troubleshoot or, see, is the system operating? Can you give me a recommendation on what I need to do? And so both the ability to empower technicians and what I'll call sort of power users, and um, the ability to assist those that, perhaps have different skills as opposed to building operations, empower them to be able to use the system at the same time. And so I'll come up, finally with one last slide that I think that I have here in terms of um, going through, really what we're trying to do is reduce resolution time, right? And this is, and you can take my numbers at face value or not, but directionally we're correct here in terms of um, get a hot call from a building in Cleveland, Ohio, and you go through sort of that workflow of go get on the EMS, create a chart, go through, look, identify faults, log the information, calculate the runtime, look at the site, determine the issue, order the parts. We go through a lot of steps in terms of systems and stop what you're doing, go over, log into this other system. Whereas with something like an AI agent, we can ask it to summarize the unit performance, include the charts and recent faults, ask it to compile this list of recent issues before a site visit. We can maybe have an idea of the parts that we need. Maybe we have an idea of what the actual issue is and be able to have the right part on that technician's truck when we go out there. So even if you don't take the numbers here at absolute face value, you can see that we can speed up the ability to discover issues, to troubleshoot, to go through in sort of real time, um, give democratized data in terms of being able to utilize that data that we're currently not utilizing all the time. So a couple of really interesting use cases for AI and connecting data and leveraging them to improve the outcomes in our buildings. I think I'm going to turn it back over to Christy here.
Yeah, thank you. So, one thing when I think about this, the resolution time, two things come to mind on this. One, in healthcare, especially in the acute care space or in a surgery center space, time is of the essence, right? Whether it's for patient safety or it's revenue, whatever might be that driving factor at that time, or maybe both. Um, if we can address needs as quickly as possible and as efficiently as possible, so having the most data before we go to a unit, I see that being a huge advantage. I also think of it from a skilled labor training perspective, right? We have an aging HVAC skilled workforce. And as that knowledge is retiring, how is that being replenished? There's only so much you can learn from someone telling you, right? It's a lot of hands on learning in this industry. And there's a lot of great resources out there, like through the American Society of Healthcare Engineers. But using technology will also supplement that training and allow them to ask questions that maybe they would be intimidated to ask to another individual. And so I think that there's an opportunity in that workforce. When I also mentioned earlier that, today, those born after 1990, that's all they know to do, right? When they need to know something, they were previously going to Google it. And now they're gonna go to Chat GTP in their own personal lives. So how are they going to use that in their professional lives? We see it from college campuses changing how they're integrating AI and AI agents into their courses. So we have to be thinking of that way in the physical environment, in the healthcare industry, and in the HVAC industry. And how do we leverage these opportunities to attract and retain labor versus turning away? And one question, no matter whom I'm speaking with, the question comes up is how do I get started? I've got a building that was built in 1970s from the Halliburton Act, and then I have a fairly new MOB with a surgery center inside, and I've got everything in between. And so I think the major takeaway is to look for a partner or look for an overlay that can bring in yesterday, today, and tomorrow's uh, technology, right? How do we loop all of those together? That way you start building a plan. The first and foremost, I would say, is getting clean and usable data. We have to make sure that, there's that saying, garbage in is garbage out. And we want to be able to provide the right steps to the AI agent when it's the correct time. But we need to build off of clean data. Um, the next piece I would just say is how do we pay for this, right? Okay, I'm ready, I'm on board, but I don't have the capital. And so wanting to make sure that you are aware of financing and funding mechanisms that are available to you, whether you're nonprofit or for-profit entities. Each of these have a different layer of complexity, or you may be familiar with some of them. They also have different incentives that can be tied to them. So making sure that you know what is out there. This presentation isn't meant to be a funding or financial conversation, but to show you that this is available, and happy to take some of those conversations offline. Additionally, bringing to you two resources. This is one of my favorite websites, desire.org. This is a repository of local and national incentives and grants that are available. You can go in and you can filter it for commercial buildings and search by your zip code, and then it will pull up what is available. And I think it's a really simple way to quickly say, I need investments in my aging infrastructure. I see the value of getting to a point of connected buildings and being able to leverage autonomous control, but I don't know how to start if I can't upgrade what I have. And so looking for those financial opportunities to support those decisions. Additionally, the American Hospital Association has grants. There's a lot of grants that are available on the rural healthcare side, but there are others that are there as well. So please check both of those out. We appreciate your time today, and your engagement was absolutely phenomenal. We can open it up. We do have a few minutes left that we can address any other questions that may have come in. Mm. All right. I don't see any new ones coming in. So again, we would like to thank you for your time. Please uh, connect with Dave or I on LinkedIn. We're happy to chat. We appreciate your time. And again, thank you for your service in the healthcare industry, and especially acknowledging you during this Healthcare Facilities Week.